So hello, my name is Ricardo Estrada, and my capstone project is on generating attacks on simple plant control networks. And my advisor is Dr. Satya Narayana. So what we have here is an image depicting what a SCADA system is. A SCADA system is a system that collects data from various sensors located at factories, plants, or in other remote locations, which it then sends to a master controller, which manages and controls this data and sends instructions to these facilities, which SCADA stands for Supervisory Control and Data Acquisition System. So the SCADA systems are used for remotely controlling industrial control facilities like water treatment facilities, power facilities, gas, oil, mass transit, and so on. So basically it enables the automation of these systems with very little human interaction. Now, because these systems, a lot of these facilities are located off the SCADA network, they have to access the internet in order to get their data to master controller. So it is at the point where they access the internet that these systems and these facilities are vulnerable to the threat of cybersecurity. So this originally started off as a group server research project at UC Berkeley, and eventually became my capstone project. And the goal of this capstone project is to develop attack scripts, which would enable us to develop various experiments of the different attack scenarios. And so we took an emulation-based approach, which basically subjects real applications, real protocols, and real operating systems to a simulated network environment. So with using this approach, the goal was to develop attacks using what's called the Deter Lab, which I'll go into in the next slide. And after developing these attacks, we would then turn around and attack simulated network control systems that I mentioned before. And then we will use these scripts to further investigate solutions to these forms of attacks. Now, Deter Lab stands for Defense Technology Experimental Research Laboratory. And it's a publicly available facility that allows for medium-scale repeatable experiments in cybersecurity. And it also provides effective containment of experiments, allowing the experimenter to freely explore the concepts of cybersecurity without worrying of an attack creeping out into the internet and causing damage. And also, it's composed of 500 computers located at UC Berkeley and USC's Information Science Institute. So what we have here on the right side is an image depicting how Deter works. So Deter works by taking a file generated by myself. In this file, we define how many computers we want to use, what kind of operating systems, what kind of applications we want to run in them. We also define the networking topology that we're going to use, and also we define what kind of events we want to happen at what specific time. Now, once you swap in this file, Deter Lab will then emulate this file. Now, we can't see what's going on in Deter Lab, so we have tools that allows us to experiment and manipulate data. Tools such as Secure Shell, which allows us to have access to a virtual desktop and also manipulate the experiment and gather data. And we also have what's called a secure experimental environment, which is a graphical user interface that allows you to see your network and allows you to see the flow of traffic on the network. And then we also have Wireshark, which is a network protocol analyzer, which captures data, the flow of packet going back and forth on the network. So what was accomplished? So I was able to successfully model cybersecurity attacks using the Deter Lab. And because of that, I was able to develop functional attack scripts called cut link, flood link, and distributed denial of service. And I will go further into these in the capstone session. I was also able to collect data on the effectiveness of the attacks, and this data will be used to determine the efficiency of the scripts against the simulated network control systems. So what we have here at the bottom is an image showing a simple internal distributed denial of service attack composed of 4 attackers, a plant, and a controller. Now, originally what happens is the plant and the controller are sending data back and forth. When the attack occurs, the attackers send a lot of attack traffic to the victim. So basically the whole goal is to flood the communication channel of the victim so that the legitimate traffic going back and forth between the plant and controller cannot get through. So eventually what ends up happening is it causes instability and eventually disrupts the communication and may lead to catastrophic failure of equipment or the system itself. So what was learned? I learned about the need for cybersecurity and the various technologies that are used to implement and explore these concepts. I also learned how to conduct research, and with that research develop scripts in a language called TCL and bash scripting. I also learned how to design, develop, and carry experiments, and also analyze the results of those experiments. I learned how to do, I learned teamwork, obviously, because this was a collaboration project with UC Berkeley, USC's ISI technical staff, as well as my colleagues from Hubble State and Youngstown State University. I also learned about persistence because the Inter Lab has a lot of issues, and one of the main things was whenever I encountered a problem, you just gotta tackle it from a different angle, because if you stop, then you're never gonna get to where you need to get to. And I also understood better the functions of an attack and how to attack systems like this, just in theory, not in real person, because it's illegal. So I don't want to go into thank you rant, so I just want to thank you guys for showing up here and letting you guys listen to how nervous I am in my capstone project. And also, if you guys want to find out more about my capstone project, I know this is not the full breadth of everything, so if you guys want to find out the whole work of this, I'll be in room 120, right across the way. Thank you.